Every commercial airplane relies on one of the simplest looking components on the entire aircraft, its tires. At first glance, they don't seem particularly special. They're just black rubber tires, not very different from the ones you'd see on a large truck. Yet every time an airplane lands, those tires are expected to handle a machine weighing well over 200 tons while traveling at around 250 kilometers per hour. So why don't they explode? Most people assume the answer is simple. Airplane tires are just incredibly strong. While that's true, strength alone isn't enough to explain what happens during landing. The biggest challenge isn't supporting the aircraft's weight, it's surviving the first second after touchdown. Here's the part most people don't know. Before landing, airplane wheels usually aren't spinning. Since they're not connected to the engines, there's nothing turning them while the aircraft is in the air. That means the airplane reaches the runway at around 250 kilometers per hour, while the tires themselves are rotating at almost zero. The moment the tires touch the runway, everything changes. In less than a second, each wheel is forced to accelerate from a complete stop to roughly 1,000 revolutions per minute. That's faster than many car engines idle, and it happens almost instantly. During that brief moment, the tire isn't rolling across the runway, it's sliding. If you've ever noticed long black marks near the beginning of a runway, those aren't made by the brakes. They're actually left by the tires during this exact moment. The rubber is briefly dragged across the pavement until the wheel finally catches up with the airplane's speed. Every landing leaves behind a tiny amount of tire material. That raises an obvious question. If the tires experience that much friction while supporting hundreds of tons of weight, why don't they immediately overheat or tear themselves apart? The answer isn't one clever invention. It's a combination of engineering decisions, each solving a different part of the problem, and it starts with the way the tire is built from the inside out. From the outside, an aircraft tire doesn't look very different from a truck tire, but on the inside, they're built for completely different jobs. A car tire is designed to last for tens of thousands of kilometers. An aircraft tire only needs to perform for a few minutes on each flight, but during those few minutes, it experiences forces that a road tire was never designed to handle. The rubber you see on the outside is only the first layer. Inside the tire are multiple layers of high-strength synthetic cords that give it its incredible strength while still allowing it to flex during landing. That flexibility is important because if the tire were completely rigid, much more of the impact would be transferred directly into the landing gear and the aircraft itself. Another major difference is pressure. A typical car tire is inflated to around 35 pounds per square inch. Most commercial aircraft tires operate between 180 and 220 pounds per square inch, roughly 6 times as much. That extremely high pressure helps the tire support enormous loads while preventing it from deforming too much during landing. Less deformation means less heat, less wear, and a lower chance of failure. Aircraft tires are also filled with nitrogen instead of ordinary compressed air. Many people think nitrogen makes the tire stronger, but that's not actually the reason. The real advantage is that nitrogen is dry and chemically stable. During landing, especially after heavy braking, the wheels can become extremely hot. As the temperature rises, so does the pressure inside the tire. Dry nitrogen provides more predictable pressure changes and reduces the risk associated with moisture and oxygen inside the tire. None of these features would be enough on their own. High pressure without a reinforced structure wouldn't work. Strong materials without the right inflation pressure wouldn't work either. Aircraft tires survive because every part of their design works together to handle the enormous forces created during every landing. But even with all of that engineering, these tires aren't expected to last forever. In fact, airlines replace them much sooner than most people would guess. Despite how tough they are, aircraft tires have a surprisingly short lifespan. Depending on the aircraft and its operating conditions, a tire may only stay in service for a few hundred landings before it's replaced. That might sound disappointing, but in aviation, waiting for something to fail is never the goal. Components are removed long before they become a safety concern. Even more surprising is that many of those tires aren't thrown away. Instead, they're retreaded. The worn outer rubber is removed, a new tread is applied, and the tire undergoes a series of inspections before returning to service. As long as the internal structure is still in good condition, the same tire can safely go through this process multiple times. Maintenance is another reason tire failures are so rare. After every flight, technicians inspect the tires for cuts, unusual wear, proper inflation, and any signs of structural damage. Even relatively small defects can be enough to remove a tire from service. Replacing a tire early is far less expensive than dealing with the consequences of a failure during takeoff or landing. Aircraft also have another advantage that cars don't. They don't rely on just one or two tires. The aircraft's weight is distributed across multiple wheels, allowing the load to be shared. On larger airliners, a single tire can support well over 20 tons, but it's never expected to carry the entire aircraft by itself. This built-in redundancy means that even if one tire fails, the remaining ones can continue supporting the airplane safely. So if aircraft tires are carefully designed, regularly inspected, and replaced before they wear out, why do we occasionally hear about them exploding? The answer usually has very little to do with the tire itself, and much more to do with the incredible amount of heat generated during landing. When an airplane lands, the tires absorb the initial impact, but they're only part of the stopping process. The brakes must also absorb an enormous amount of energy as they slow hundreds of tons of aircraft from landing speed to a complete stop. During a heavy landing or a rejected takeoff, brake temperatures can exceed 500 degrees Celsius, and some of that heat eventually spreads into the wheels and the tires. As the tire gets hotter, the pressure inside it increases. If that pressure continued to rise without any protection, it could eventually become dangerous. That's why aircraft wheels are fitted with thermal fuse plugs. These small metal plugs are designed to melt at a specific temperature, allowing the tire to slowly release its pressure before it can rupture. Instead of exploding, the tire is intentionally deflated in a controlled way. Of course, not every tire failure is caused by heat. Sharp debris on the runway, excessive wear, or unusually hard landings can also damage a tire. But considering the conditions they operate under, failures are remarkably rare. Every part of the system, from the tire's internal structure to its inflation pressure, the nitrogen inside it, and the aircraft's maintenance schedule, is designed to reduce that risk as much as possible. So why don't airplane tires explode on landing? Because they're not ordinary tires. They're highly engineered components built specifically to survive one of the most demanding moments in aviation. In less than a second, they accelerate from almost 0 to around 1,000 revolutions per minute, support more than 20 tons each, and endure forces that would destroy an ordinary road tire. The next time you watch an airplane touch down, it's worth looking at the wheels instead of the wings. That small cloud of smoke you sometimes see isn't a sign that something went wrong. It's simply the moment when years of engineering do exactly what they were designed to do.